All right, let's take a look at alloys. So alloys are basically metals, but they're just stronger versions of metals. So in the previous video, we took a look at metallic bonding, and the reason metals aren't so strong, by metals I mean pure metals, so metals made up of just one type of element, the reason they're not as strong as alloys, and the reason that they're malleable, so being able to be bent or hammered into shape, is because all the atoms are arranged in single rows, because it's one type of atom, right? So they can all slide about, and that leads it to being not as strong. But alloys are contain two or more different atoms. By atoms, I mean elements. Two or more different elements. So two or more different elements are mixed in together. Usually it'll be a combination of two or more different metals, but sometimes it could be a metal or a non-metal as well. And you'll notice this pattern of two or more a lot. Molecules are two or more atoms, and compounds are two or more different atoms. So I don't know, I just thought that it's interesting. We get a pattern of two or more things being required to be something. It just happens a lot. Just thought it was interesting. So it's two or more different atoms. Why is this important to making the metal stronger? So in order to become an alloy, the whole point of having two or more different atoms is so that the atoms can be of different sizes. The point isn't to have two or more different atoms. The point is to have differently sized atoms. Differently sized atoms. Because pure metals, right, made up of just one atom, one type of atom, it's all going to be the same shape and size, right? So when you have them in rows like this, they can slide about, leading to they can move about, so they're malleable. But when you have differently sized atoms, just look at what happens. For example, we could have atoms of iron, so iron is Fe. And the way we make steel is we combine iron with just a little bit, just 1 or 2% of carbon. So we could have a bit of carbon and then iron again. And then carbon here. Now, what this allows us to do is, you see, the shape isn't straight, right? Because we have these carbon atoms stuck in between these iron atoms. I know I didn't draw these iron atoms like in a straight line, but you get the point, right? If you have differently sized atoms in between these atoms, they're going to block a smooth path from forming. And so it's going to prevent them from moving about, right? And that's going to make them stronger. So pure metals aren't so strong, and they're malleable because they only contain one element, right? So it's one type of atom. So everything is arranged in a regular structure, allowing different layers to slide over one another, leading to it being malleable and not as strong as alloys. And that's why alloys, so it's a mixture of different atoms, right? Different atoms, so it's different elements, and they're differently sized. The point is that they're differently sized, preventing them from moving or gliding over one another and making it stronger. And the notable example is steel. Steel is made up of iron atoms, so Fe, and carbon atoms. They're both mixed in together, and the carbon atoms are just 1 to 2%, but just a small amount prevents it from sliding over one another, thus preventing regular structures from forming, and so the layers don't slide, making it stronger. And it provides the strength needed to be used in cars or planes. Steel is used a lot in cars or planes. And that's what alloys are. It's basically just two or more different elements combined together to make the metals just a little bit more stronger, to prevent these uniform layers from forming and to make it a bit more bumpy so that they can't just glide over one another, to make it more stronger. That's what alloys are.